Okay, getting back to our Laplace Transform playlist, I still have a few formulas that I want to add. So today we're going over the Laplace Transform of t times f of t. And to get started with this, first what I want to do is we want to just look at our definition for the Laplace Transform. If we have the Laplace Transform of some function that we're going to call f of t, then this is just going to be the same thing as the integral from 0 to infinity of f of t e minus st dt. And what we can do for this is use some notation. We can just call this big F of s because what's going to happen here when we do this integral, the result of it is going to be a function in terms of s. So now using this for the thing that we want to find, this Laplace transform of t f of t, we can just kind of use that. I'll use a different letter. We'll call this big G of s, which I'm going to use to be this Laplace transform of t f of t. And so just using the formula, what's going to happen is now, like our f of t, I guess we could say this is actually now g of t for what we want to find the Laplace transform of. So that's going to be, we can just plug this value in here and we get t f of t e minus st dt. And so the reason I started with our original definition is I want to go from here to here. I want to take this formula and I want to somehow create this t right here. Then what I can do is kind of use this starting here and take a derivative. So what I want to find is the derivative of this big F of s. And again, this is a function in terms of s, so we're differentiating with respect to s here, and we're going to differentiate this thing right here. But then at this point, what we need is going to be Feynman's trick, because we need to differentiate under the integral sign. And so how we're going to do that is we'll just rewrite it, but now this, we'll have our integral, but then this is going to become a partial with respect to s. And the nice thing about doing this with the Laplace transform is we already have our parameter. We already have two variables here. We have our s, so this is really set up for us. Now the important thing to remember here is that t is just a constant value with respect to s. We're going to differentiate with respect to t later, but right now for this derivative, we're just looking at the s value right here. So then just taking this derivative, what's going to happen is first, this f of t is a constant, so we'll just bring that in front here. Then taking the derivative of e minus st with respect to s, first, we're just going to get e minus st. Then we need the chain rule on this part. That's going to be a minus t, which I'll just pull in right there. And then we have our dt. But then I can just take this minus sign and bring it up front of the integral. Make that a plus there, bring a minus there. And then what we notice is what we have right here, this whole integral, this is exactly the same as our goal that we have right here. This thing is just the Laplace transform of t f of t that we have right here. But now one last thing I can do to finish this off, let's just take this minus sign and we can put it on the other side of the equation with our derivative. But now we've isolated exactly what we want to find. And so for our formula for the Laplace transform of t f of t, we just have minus big F prime of s, and that's it. Okay, there you have it, Laplace transform of t f of t. Thanks everyone for watching today. Have a good day.